Hello. Lovely to be here. I'm Pari Singh. I'm the founder and CEO of Flow Engineering. Let's talk a little bit about digital transformation. We've heard about digital transformation every single year for the last decade. We've heard about Industry 4.0 every single year for the last decade. Digital transformation promised a whole bunch. It promised how it would revolutionize engineering and everything about everything. And we're a couple of years in, and some of the early ideas that we had are actually in production now. So we thought it would be a good idea to look back over the last couple of years to understand what's gone well, what's gone badly, and then to look forward to say what's the next phase of digital transformation, where are the problems that we need to actually go solve. Well, digital transformation is a very big term, and to be able to answer the question on what's going well and badly, we need to be able to answer a much simpler question, which is exactly what is digital transformation. If I ask 10 of my friends this question, I'll get 10 different answers. I imagine if I ask 10 people in the crowd today this question, we'll get 10 different answers. Fundamentally, we believe that digital transformation is already happening and has been happening for the last few decades. As engineering teams, we've gone from hand calcs on pen and paper to spreadsheets and MATLAB and sometimes Python. We've gone from drafting tables to parametric 3D CAD. We've gone from physical testing every single design to a mix of physical testing and simulation. We've gone from a pen and paper first world to a digital first world. That's happened, that's great. The promise of digital transformation is that we can further streamline and make efficient the engineering processes if we let these tools that are in the computer speak to each other. So the core of digital transformation is about integration. And when we look at digital transformation today, we've done a really, really good job on some of that. From the 3D design to simulation, to manufacturing, to IoT, to sensors, to getting live readouts from products in production. We've done a great job at being able to link these different elements of the world together and build some initial streamlining of process in there. But we believe a really core part of that has been missed. And that core part is the stuff that maybe happens at the same time or before CAD. It's the engineering architecture, it's the engineering decisions, it's the analysis. It's where your electrical engineer and your mechanical engineer and your control engineer sit down in a room and say, how are we going to solve this problem? All of that engineering design and thought is currently still done by people in Excel and in CAD and sometimes in MATLAB. And that's still done by people sitting in a physical meeting room and having a conversation in front of a whiteboard. All of that information is still shared via Excel, via email, via Microsoft Teams. And that process is really hurting. When you speak to engineers, mechanical engineers, electrical engineers, chemical engineers, whatever sort of engineers, and you ask them how digital transformation has helped them in the last couple of years, typically they say it hasn't really got to us yet. When you ask them how their engineering design, how their day and how their productivity is, they say, well, a couple of years ago, I used to be able to spend 70% of my time just heads down and focused designing stuff. Today, I spend 30% of my time doing that because all of these changes happening around me are constantly bombarding me. I need to rebuild models, reanalyze what's happening, and share my information continuously. So why is this happening? Why is this getting harder and harder year on year? Well, the answer is quite simple. The answer is complexity. Our products have got significantly more complex over the last couple of decades to today, and moving into the future when our products become more and more softwareized, as our products become more and more complex, that problem gets significantly worse. Our engineering systems have gotten more and more complex. They've got more and more multi-disciplinary, and they've got more and more interdependent. And that interdependent is really the key to understanding why things are more painful and harder today. If you imagine this is a system, this is a team working together, every extra engineer that you add has n+1 more connections, which just means every additional bit of complexity doesn't scale linearly, it scales exponentially. It gets harder and harder to collaborate with a team of 10 versus 8. It gets even harder when you're 12. It gets even more difficult when you're 15. And go into a team of 20, 50, 100, it's a whole new world. Today, because our systems are complex and interdependent, because our collaboration is happening across different teams, in different tools, sometimes in different time zones, one change in one place, in a spreadsheet or a CAD model, will cause 3 or 4 changes in other places. each one of those causes 4 or 5 more changes. Every change has a cascading knock-on reaction, a chain reaction of events. And this isn't just happening in one part of your design team, it's happening everywhere in your design team all at once. And that's really painful for engineers because they've got a difficult decision to make. And that decision is, do I spend my time heads down, focusing on my part, knowing that I'm probably not up to date with the rest of my team and have some incorrect assumptions? Or do I try and sync with the team, but then not have enough time to actually do my work? Fundamentally, this is a driver to extending timelines. This is every 2 hours of a day being spent on email, being spent on Microsoft Teams, going into a 1-hour design review. That turns into a 2-hour design review. That turns into a 3-hour design review. It's the cause of a lot of problems. And in today's market, where time to market is absolutely everything, where you're trying to get stuff out the door and into customers' hands as quickly as you can, any efficiency that makes that more difficult should be reviewed. So that's why we built Flow. We are trying to solve a small part of this problem. We're not trying to promise that we're going to solve everything. And our goal is to help multidisciplinary teams collaborate better, integrate better, and streamline their engineering process. So when we speak to engineering customers, whether they be consultancies or OEMs, large scale, small scale, whatever, we typically ask them, how do you guys share key design data and track that as it changes? And the typical answer we get is, oh, we put all the design data into Excel, we put that into SharePoint, and then that is the source of truth for all the design data. Sometimes it's not Excel, sometimes it's a Word document, sometimes it's a PowerPoint presentation, sometimes it's a wiki on Microsoft Teams or on SharePoint. But there is typically one place where you put what we call static data, and you expect your team to be able to collaborate around that. Our goal with Flow is to make this process better. So Flow is the home for your team's design parameters, and in some cases, requirements too. It's a cloud-based, intuitive, single source of truth for live engineering data. As you can see, you can search and subscribe for data. You can find out who owns the specific bit of data that you need. And most importantly, you can subscribe. If you subscribe to someone's data, whenever they make a change, Flow will let you know immediately through a push notification or an email. This is what keeps teams up to date. Flow, at its core, allows engineering teams to make changes, to track those changes, and to keep the entire team up to date so your team doesn't need to spend the time to. This helps catch issues ahead of time. It helps catch when your engineers are using the wrong data and don't even know about it and find out in the design review a few weeks later. And finally, with every single change that's made, Flow tracks it. So you can look back and understand who made a change, why they made a change, when they made a change, and the consequences of that change. As teams come onto Flow, we are finding that they would like to directly link this single source of truth for data into their engineering tools, whether those tools be CAD tools, or they be analysis tools like MATLAB or Excel, or those be simulation tools. We're really excited today to be able to announce our partnership with Autodesk. As you're well aware, Autodesk is one of the largest CAD players in the world, and we're going to be integrating Flow directly in with Fusion 360 and later Inventor to be able to further streamline this engineering process. Basically think user parameter on steroids, being able to ingest that directly from the rest of your team's tools. And that's it. If you would like to continue the conversation around digital transformation, we would absolutely love to hear from you. And if you'd like to get hands-on with the tool, it's currently in private beta. We're giving it away for free to anybody that wants to come on early. Please follow the link, sign up, and we'd love to hear your views. Thank you very much.